If it's yourself or your family or a friend that's on the table in the OR, you want the best surgeon possible. You want them to be great. And a lot of them are. What they can do is incredible. But we want to take that actually a step further. We want to start to give them superpowers.
The challenge of seeing what you're doing when you're trying to navigate through a complex three-dimensional structure using a two-dimensional, fundamentally limited way of imaging, it really made me realize that the big challenge was actually in implantation, not in planning procedures. Our team set together to develop a better way to navigate. So the IOPS technology is a lot like GPS satellite navigation, except it's for the inside of a human body instead of for the planet. The electromagnetic tracking technology we use is a lot like the GPS satellites in orbit and the little antennas in our cars and phones, but then IOPS brings it to a whole other level by bringing in a level of intelligence that allows the system to give interactive, real-time guidance, navigation, and control. Our central design goal of being instantly intuitive made augmented reality and extended reality a natural extension of the IOPS platform. From the very beginning, we had a heads-up display planned, and when the Microsoft HoloLens became available, we realized it was the perfect platform to implement our next-generation IOPS technology.
There's danger to the physicians as well as we use radiation when we use fluoroscopy. The more complex procedures get, the longer they are and the more radiation we're exposed to. That's not just a risk to the physician, that's also a risk to the patient.
When Dr. Greenberg approached me at the program of computer graphics at Cornell, his idea was that we needed to find ways to make surgery better through computation. And so we had developed this technology to take raw CT scans or other medical images and generate a computerized map of what the anatomy is in there. So we developed a way for a computer to make meaning out of medical images that was really hard to do before that.
We're not used to seeing images of such clarity, such depth, such three-dimensional kind of aspects. We're not used to seeing that, and so my reaction is exactly the same reaction to everyone who puts on the HoloLens or steps forward with a catheter or wire and tries to manipulate in the body. It's wow. It is a fundamental change. And so, I very much look forward to using more of this.
I love it when you get somebody to put the thing on for the first time. A lot of times we'll get something stronger than a wow. A lot of times we'll get an expletive out of somebody the first time they put it on, which is really great.
Why do we still do angiography using fluoroscopy and contrast 60 years later? I ask myself every day, when can I use this? I keep having to restrain myself from badgering people in your company saying, I want this now, at least for vascular access.
I think the biggest safety advantage of IOPS will be the improved visualization of the vascular anatomy and our ability to track better where are we within that anatomy. We can do that on a three-dimensional basis, which we can't do with current fluoroscopy.
I personally feel very passionate about what we've created. Having lost someone that's close to me to cancer when I know that he was exposed to a lot of radiation to provide care, I want to create a system, a world where that's no longer the norm.
It has, in my opinion, immediate applications, not just to transvascular access and catheter and wire-based manipulation, but also thinking beyond the realms of cardiovascular or vascular disease, tissue biopsies, epidural spinal anesthesia, regional nerve blocks. It's time for us to evolve in the way in which we image cardiovascular structures live and deliver transcatheter procedures. And so I think with the advent of augmented reality, therein lies a fantastic opportunity to fundamentally change the way in which we practice in the coming decades.